Okay, hi everyone. I'm Joel and this is Gina. We're here to talk to you today about LingSync and the online linguistic database. These are open source, web-based tools that facilitate fieldwork and collaborative approaches to fieldwork on endangered languages. Our initial goal in this presentation is to just provide you with an overview of the two systems. But right now we're kind of at a transition point because we're beginning to merge these tools under the name LingSync, and we're interested in getting your feedback on our approach, our general approach. And because we know you guys have thought a lot about this type of issues we're confronting, and we're just very excited to be here to be a part of this discussion about how computational tools and computational linguistic advances can help benefit fieldwork on endangered languages. So it hardly needs to be stated that we're in a situation where a significant portion of the world's languages are predicted to be extinct or sleeping in the very near future. And linguistic diversity and vitality are valuable from a number of perspectives. For those who might be skeptical about the strong link between language vitality and social well-being, this Hallett reference is to, it's an interesting study, shows a high correlation between higher levels of Aboriginal language use and lower youth suicide rates in First Nations bands in British Columbia, Canada. So that's interesting. But anyways, we're here to talk about, we're all here because we think computational approaches can contribute in interesting and useful ways to documentation, study, and or revitalization of endangered languages. So there's a number of ongoing debates that are relevant here. First, there's some disagreement over how we should approach the urgent problem of language endangerment. Some argue that we should focus on documentation, recording speech, re-speakings, and translations, as Stephen Bird's that presentation just showed, and generating artifacts for future study. Others point out that we can use computational tools and computational linguistic advances to expedite language description and analysis, and this way we can avoid an unfortunate eventuality which sees a bunch of data that nobody can make sense of. And then there's also a related debate over what is the role of theoretical linguistic analysis here. Some typologists strongly advocate a position where they're arguing for a descriptive approach, and on the other side, theoretical linguists are responding in a defense of a hypothesis-driven approach with its attendant elicitation methods which are controversial to some, like translations from the meta-language and eliciting judgments, right? So this Murray paper is a recent defense of the hypothesis-driven fieldwork approach, but anyways, it's an interesting debate. Another related debate is whether the various types of endangered language fieldworker have a duty to collaborate, and relatedly, whose agenda should be given priority. At one extreme lies the view that the interests and goals of the linguistic fieldworkers should be subordinated all the time, basically, to those of the language communities. And then others point out that for a variety of reasons, this is not always possible or desirable. The contexts of language endangerment themselves are diverse. And not all communities desire or are genuinely committed to documentation or revitalization, and not all communities need or desire the help of academic fieldworkers. In some cases, the political landscape of an endangered language community is just too complex for a field linguist to navigate. So anyways, it's a complicated issue. Kind of our approach is that we want to sidestep these issues to a certain extent and advocate something along the lines of can't we all just get along, and we want to help contribute towards an infrastructure which facilitates but does not require collaboration between stakeholders, and one which is flexible and general enough to be useful to different types of linguist and fieldworker. We want to help fieldworkers to make their data more useful to their peers. So this is kind of a high-level overview of the role we see that LingSync and the OLD can play in endangered languages fieldwork. The software helps fieldworkers of various types and with different goals to share data and collaborate if they want to. And as we'll be discussing, it offers features and conveniences which respond to the requirements of different types of fieldworker and fieldworker situation, which may make the system worthwhile beyond the primary collaboration and data sharing functionality. So this is a brief legal review of the list of requirements that guided the development of these two tools. We're not claiming that these tools fully meet these requirements, but these are goals we're working towards. So we want to integrate primary data. In particular, we want to allow fieldworkers to more easily share audio and video recordings. The system should allow for alignment of audio, video with transcriptions and other textual data, and you should be able to display them simultaneously so you can easily cross-reference, and recording audio right into the application would be beneficial, and automating the alignment process would also expedite things, right? Systems should facilitate curation of data, that is, its iterative and collaborative refinement over time. For example, the initial output of an elicitation could simply be an audio recording and transcription of the forms that are relevant to the field worker, and then subsequent waves of data curation can involve transcription at various levels or the creation of morphological analyses and annotations of various types, categorizations, and we can automate that to a certain extent. And as was alluded to before, we want to include the various stakeholders in the process. So we want the software to be useful to linguists with various types of expertise and agendas, so theoretical, typological, historical, computational, comparative linguists, whatever it is, to other types of academic researchers, say anthropologists, interested community members, and field workers engaged in community-based documentation, education, and revitalization projects. We want to make the data open so that it's available for reuse via various graphical user interfaces and APIs, and also it should be configurable so that you can restrict access if that's necessary, because some communities have requirements like that, right? It should contribute to user productivity, so we want well-designed interfaces and conveniences which expedite repetitive tasks. And it should also help with tasks that are particular to linguistic fieldwork, such as the creation of sophisticated searches for research. That's one example. So this diagram depicts how we see LingSync and the OLD with respect to some of the other tools currently being used by field workers. Like data and general purpose database and spreadsheet applications, the data in LingSync and OLD are structured, which facilitates programmatic interaction. Like Flex Toolbox and Elan, LingSync and the OLD provide features specifically designed to facilitate fieldwork tasks, so like presenting data in interlinear gloss text format, modeling components of the grammar, automating the morphological parsing task, and exporting to formats that linguists use. And finally, like applications like Google Spreadsheets, LingSync and the OLD allow multiple contributors to share data and perform fieldwork tasks collaboratively. So this table compares the LingSync and OLD to a number of other software tools used by fieldworkers. I guess in particular we want to note that LingSync and the OLD functions online and offline. It works on all major platforms since it's a collection of web-based components. We have version control so that modifications can be undone. It exposes a simple API to facilitate programmatic use. And we have some advanced search capabilities. It's open source and has relevant import and export features. So this is the high-level overview of the LingSync architecture. The core components are the Corpus web service, where the bulk of the user data are stored, and two primary graphical user interfaces, the spreadsheet one and the prototype one, which mediate user interaction with the Corpus web service. The audio web service can identify utterances within large files and can align transcriptions and audio files using another tool called Prosody Lab Aligner. And the parser component here is the OLD's morphological parser functionality, which I'll be discussing in a sec, but it's not currently integrated into LingSync. So this is what LingSync Corpora look like. So a field worker can create any number of corpora, and then they can grant access at various levels to any one of their corpora. And a corpus can be made entirely public so that it can be accessed without any kind of authentication necessary. Portions of the corpus can be encrypted if that is needed for fine-grained control over data access. And then, as I said before, we have version control so that you can undo modifications, which is important when you're doing collaborative data curation and elicitation. So I guess I want to say that the data structures assumed by LingSync and the OLD are arguably more general than those of similar applications like Flex and Toolbox. And this greater generality allows these tools to be useful to a wider range of field workers. So under the LingSync OLD conception, the fundamental unit of data is something quite unconstrained, which in LingSync is called a datum, and the OLD is just called a form. And this abstract data unit may be used to represent sentences, phrases, words, or morphemes. And then you can build texts, corpora, and records of elicitation sessions out of references to these more abstract entities. And then similarly, grammars can be created which reference these entities as examples, right? And dictionaries could be constructed from these units as well. This contrasts with the data structures that underpin Flex and Toolbox. These tools assume that a grammar and a dictionary with supporting text are the ultimate goals of the field workers who use them, which is not always the case. This table shows some stats on the extent to which LingSync is being used at present. So we have 300 users, 400 corpora, and 24,000 documents, which are these abstract units, these datums that I was talking about. And here we see the extent to which the OLD is being used. So OLD applications are a little bit different. They are language-specific, independent entities. Here we see fieldwork is being performed in 9 endangered and or underdocumented languages using the OLD. And so Blackfoot, Nata, Gifsan, Okanagan, and Tlingit are currently seeing the most use. And the speaker population figures in the rightmost column are from Ethnologue, and they're probably optimistic and or out of date. So, but in any case, these languages are endangered to highly endangered. So these usage statistics, while perhaps modest from certain perspectives, are nevertheless indicative, we think, of a need for software like the OLD/LingSync.
So now I'm going to show you some screenshots of some of the more interesting plugins we have. We have over 20 plugins for the system, but I'm going to just show you some for audio processing and lexicon visualization. So this is the Kartuli speech recognizer, which is an Android app on Google Play. You can download it on your Android. It was built during last semester while I was in the field in Batumi with some local software developers and students. The app uses the LearnX user interface, which is another Android app we have, to let the users train the app to their own voice and their own vocabulary. So any sentence the user says becomes a datum in their corpus and is then used to further retrain their own language model, which we hope to help improve recognition rates for Kartuli. Kartuli is an agglutinative language, unlike English. Most speech recognition systems are not designed for these languages, and we're using Sphinx, I'll mention since we have someone from Carnegie Mellon here. If you have other questions, come see us at the demos. We'll show you it. You can get it on the Android Play, and it's intuitive. It's all audio prompts. Here are 2 lexicon visualizations that we have. The first lets you see the precedence order of morphemes. So this is the start of the word and the end of the word, and you can see the path of morphemes. This data comes from Emi's dissertation on the interactions of the morphemes Naya and Ta in Cusco Quechua. And in fact, you can see this through the graph. You can see that they're the focal point of the graph. This is just a static representation of the graph. When you open it in your browser, it flies around and then settles. The second visualization is a word cloud visualization that Josh built using Jason Davies' word cloud engine, which is all in JavaScript, not in Java. So the existing one, Wordle, which is really popular and beautiful, is using a Java applet, which won't run on iPad, Android, and many modern browsers. So this uses all JavaScript, and we made an interface that if you click on a word, our language consultants can edit the head word, edit the gloss, add morpheme segmentation, or declare that this word is a functional word and not informative, and hide it from the word cloud. And this lets the users visualize the content of a document really quickly, and is handy for search. So I'll turn it over to Joel, who's going to talk about Parser.
Okay, I want to quickly discuss the OLD's morphological parser functionality. I want to present and motivate the approach, and then just reference 2 parsers that were created for Blackfoot, an endangered language which is from the Algonquin language family, and which is spoken in Alberta, Canada, and Montana, USA. So I think this portion of the presentation will segue nicely into the next one, which is about a similar task on another endangered Algonquin language, if the program is still what it was yesterday. Okay. So here are the requirements that I had in my mind when I was doing this. So I want field workers to be able to create morphological parsers that are practical and forgiving. By practical, I mean they should be able to suggest correct or largely correct word analyses during data entry. And by forgiving, I want field workers to be able to create these parsers without first having a full and complete analysis of the morphophonology of their language of study. And since they're being encouraged to create them themselves, they should be able to do so using the skills they already have with minimal modification. They shouldn't have to learn unfamiliar formalisms if it's not necessary. They should make use of the data in the system, such as interlinear gloss text data and phonemically transcribed and categorized lexical entries. And you should be able to tailor them to a specific purpose. So you should have orthographic parsers for descriptive tasks, for prescriptive, like spell checkers, and then phonetic parsers for testing models or creating pronunciation dictionaries. And since they are comprised of computational implementations of models of the lexicon, morphology, and phonology, they should facilitate the automated testing of these analyses and models against the specified data sets within the system. And so, yeah, it would be nice if they could be reusable for other components. So this is the kind of the high-level overview of the components of an OLD morphological parser. It's just a finite state transducer that takes a service transcription as input and returns a set of candidate parsers as output. That transducer is a composition of a phonology and a morphology, all standard stuff from like Beasley and Cartoon and stuff, right? And then the candidate ranker assigns a probability to each candidate parse returned by the morphophonology, and it's just an n-gram language model. So the phonology is a transducer that's defined explicitly and in its entirety by the field worker as an ordered list of context-sensitive rewrite rules. So here we have a Blackfoot example. On the left is the morphemes and phonemic transcription, and then a phonetico-orthographic surface transcription on the right. And then here we see a phonology that implements that mapping. It's written in the regular expression rewrite rule language that is accepted by FOMA and XFST, and it should be transparent for anyone who's taken like a Phonology 100 course, right? All you have to learn is that the two vertical bars are a / and then you can just use your speech pattern of English knowledge to write a phonology. It gets a little more complicated than that, but yeah, that's the basic insight. Okay, so since the field worker has full control over the definition of the phonology, they can use the parser to automate the discovery of words in the database that the morphophonology cannot analyze. Right. I need to stop, so I'm just going to quickly point out that so you can extract this kind of morphotactic and lexical information from the IGT data, and then you can extract the trigram counts to create an n-gram language model. You can make reuse of the data in the system. So I'll just quickly get to the results I got. So the overall success rates are not super impressive, but the F-scores show that these things should be practical in expediting the creation of interlinear gloss text data. And if you have a good user interface to help you browse through the data, it should expedite the task. Anyways, I can talk to you more about that, but I should probably stop. So do you want to?
Sure. I'll just conclude really quickly. So for more information, you can also search LingSync on YouTube. You'll see interactions with the actual user interfaces. We wanted to keep it really general and open today. Basically, we wanted to show that fieldwork in endangered languages is not trivial, and that the software we have existing doesn't cover all the space that you need to cover in order to get work done efficiently without wasting time. So we needed to include all stakeholders, all devices. Our solution for this was modular web services and a plugin architecture. Everything we did is open source. It's all open development, which means you can see the issues as we track, as we plan, as we make future milestones. We're completely public about our plans. We facilitate open data, but we don't enforce it. And we're trying to synthesize fieldworker and computational linguistics expertise. We'd like to thank all of our interns. We had a lot of computer science interns, linguistics interns, our language consultants who shared their language with us, a number of granting agencies, and of course you guys and our users for giving us feedback, asking tough questions. We're not afraid of them. You may ask. I think we have 2 minutes.
Is there a tough question then?
You can also come up to us personally. We both are programmers and linguists, and we've done both sides of the fence, and we're happy to talk to anyone about details. We will also be demoing anything you want later.
So you had a success rate there, but this is something where the parser is actually evolving as you're doing through checks. So when were you taking that measure? I mean, did you have some particular?
I specified a certain corpus that I filtered out and said that was the gold standard of well-parsed data in the database.
So you had some specific corpus, and then you went through an exercise of as if you were transcribing it, and then see how well it did after that.
Yeah, well, the analyses and transcriptions were already created by the users collaboratively, so I was able to get 3,500 gold standard morphologically analyzed words and use that to create training and test sets.
I'll add one thing that Joel pointed out earlier. Even though his F-scores are low, his job is really automating the field worker's job, and he's pointed out that the right candidate is often in the list of alternatives to the field worker, so it's in a type ahead, so that you can get to your candidate much quicker than typing it itself. So even though the F-scores are low, which is bad for computer science, it's actually perhaps meeting the task.
Well, the transducer is a 60% success rate, so the solution's in there 60% of the time.
Any other questions? Thank you very much.